Hello everybody, welcome to another video lesson. Today we're going over conversions between polar and rectangular forms. After this video, we'll be able to convert coordinates as well as equations from polar form to rectangular and then from rectangular to polar form. So let's hop right into it with our concepts of converting just coordinates first, okay? When we're looking at converting from polar to rectangular, okay, we have our setup here. We've got an x-axis, which is also sort of like our polar axis in this sort of scenario here. We've got our y-axis along with our pi over 2 axis here. Okay, so we're kind of looking at polar form and rectangular form in the same grid here. And we've got some point up here, and we are looking at this in terms of a polar point here, polar coordinates. So we've got theta and r. However, we can also take a look at this in, if I were to imagine this as a vector, right, we could look at the components of this vector and kind of make this right triangle here, right, with x, y, and r. And I know that the x component here would be expressed as x is equal to r cosine theta, right? And y, similarly, would be y equals r sine theta. Now, we use these when we derived our distance equation, our distance formula rather, for polar coordinates, okay? So this is something that we've kind of seen before. All right, so it's as simple as that, guys. When we're converting from polar to rectangular, our new rectangular coordinates, x, y, would just simply be r cosine theta and r sine theta. That's it. All right, now looking from rectangular to polar, a little bit different here. Okay, now we've got our same sort of setup. We've got this right triangle with components x, y, and then r as this hypotenuse. We've got angle theta here, and we've got our x-axis or our polar axis, and then likewise we've got kind of this circle going on, looking like we're in polar form. Okay, so r now, if I were to use my Pythagorean theorem, right, I would say that r squared is equal to x squared plus y squared, right? So if I solve that for r, I take the positive square root, because r I know is just is a distance, right? Now it could be a negative value, right, r, but overall when I'm looking at this graphically, r is just some distance, okay? So I'm going to take the positive square root of both of those sides, and I get square root of x squared plus y squared. Okay, so that is how we can find our r value then. How about our theta value? Well, let's see. If we look at tangent of theta, right, we're given the coordinate x, y, so we have y and x. So tangent theta is going to be equal to y over x. So I just need to take the inverse of both of those sides, and theta is going to be equal to inverse tangent of y over x. Okay. Now remember this, guys, from when we went over our inverse trig functions. Okay. Inverse tangent is defined on this very specific interval of negative pi over 2 to pi over 2. Okay. So therefore, if our x value is negative, meaning we are in quadrants 2 or quadrant 3, okay, then my equation changes a bit, because I need to add pi to my inverse tangent equation in order to get my theta value. Okay, so if I have some theta value that puts me over here in quadrant 3, if I add pi to that, it's going to bring me back around to quadrant 1. Okay, so keep that in mind when you are working with your inverse tangents, thinking about what your angle is and where inverse tangent is actually defined. All right, so that is our coordinates. Now, how about converting equations? Well, it's very similar. We're going to use the same relationships that we use for our coordinate conversions. However, now we're going to use our other trigonometric functions to manipulate and simplify things, okay? So I strongly, strongly, strongly recommend you go back and review the trig identities from previous units, because those are going to be very, very helpful. You might be asking, why do we want to do this? Well, some equations in polar form are just kind of nasty, like this one right here. Okay, I've got 6 over 2 cosine theta minus 3 sine theta. If I were to convert that to rectangular form, that's just a simple line that we can see and graph pretty easily, right? Okay, so that would be one reason for us to convert between different forms of our equations, okay? So that's it for our concept, guys. Let's get right into our examples here. We've got quite a few today. So we're going to convert our coordinates from polar to rectangular. So again, my r value is just, or sorry, my x value is going to be r cosine theta, y is going to be r sine theta. So we can just go ahead and plug those in, knowing that r is -6 and theta is -120 degrees. Okay, so we've got x here, y here. We're just plugging these values for r and theta straight in. X would be then -6. Cosine of -120 is -1/2. And sine of -120 is -√3/2. Okay, so we just substitute those values in and simplify. So my x value would be 3, because that would be -6 over -2. And then my y value would be -6 times -√3/2. So that would simplify to 3√3. Or if we looked at this and approximated this in decimal form, this would be 3 and 5.196. Okay, and we can sort of verify this on our rectangular coordinate grid here. Okay, so I put my x coordinates in integers, and then I put my y coordinates in terms of pi, just so we kind of see what's going on. Okay, so I would have -120. Okay, this is kind of my reference that I'm looking at here that we have for this polar coordinate. Okay, -120 degrees. And then we would go the opposite way, 6 units here. Okay, so 6 units would be the length of this vector to land us here on this point. Okay, and this point would be our 3√3. So using that exact same logic, that exact same process, go ahead and convert 2 and then pi over 3 into rectangular form. Pause the video and see if you can do that. Alrighty, hopefully you got 1√3, or in decimal form 1.732. Okay, and this would be kind of our reference graph to help us verify that. Okay, now let's take a look at going from rectangular to polar, and we can find multiple pairs of polar coordinates, guys. Remember, because we have multiple representations of the same point. Okay, so we're given the coordinates 8, 10. Let's go ahead and use our relationship for r equaling the positive square root of x squared plus y squared. That's going to be the square root of 164, which is approximately 12.81. Okay, now we are in quadrant 1 here, right? I've got positive x, positive y. We're in quadrant 1. So I can just use theta equals tangent of y, or sorry, inverse tangent of y over x. Okay, so we can plug in y as 10, x as 8. And we would get approximately 0.896 radians. So that would be our coordinate right there. Now it asks for 2 pairs, so we're going to find 3 just so you guys can kind of get used to this here. So our second pair of polar coordinates that we would find, we're just going to add 2 pi to this. Okay, adding 2 pi takes us all the way around, okay, 1 revolution around the pole, right? And so I can keep the same r value, okay, and I'm just going to change this by adding 2 pi to that. So I can plug this directly into my calculator, and it'll spit out a decimal approximation of 7.179. So that would be my second coordinate pair. Now, if I were to restrict this theta for whatever reason, okay, you may need to use a negative r value. So when you do that, you would then add or subtract pi from your original theta, okay? So if I were to go a half circle or a half revolution around the pole, then that is what adding or subtracting pi is essentially doing, right? So in this case, I would have my radians, and I would add, and this is the radians from our original calculation. I'm going to add pi to that, and that gives me about 4.04. So I can have another polar coordinate that is negative 12.81, and then my theta value is 4.04 radians. So multiple representations can give us multiple different points here that essentially land us on the same coordinate here of 8, 10. So using that logic there, guys, go ahead and see if you can't find just 2 polar coordinates for these given rectangular coordinates of -2, -4. Pause the video, see if you can find it. I got 4.472 for my r value, and for my original theta value, that was 4.25, okay? And again, we were in quadrant 3 to start off with, so we had to add pi to that, okay? We add pi, we get 4.25, and then for my second point, I just added pi again, and that gave me 7.39 for my other point, but then I flipped my sign for my radius, or sorry, for my r value. Alrighty, so that was coordinates. Now let's take a look at equations. So going from rectangular to polar. Okay, write each equation in polar form, and then we're going to identify what type of graph this is, or what type of curve we're dealing with. And hopefully we can already kind of see from previous units what this curve is going to be. But let's go ahead and write this in polar form first. So I know that all my x values are r cosine theta, and all my y values are going to be r sine theta, right? So I can just go ahead and take these equations and use substitution in here. So everywhere I see x, I'm going to substitute r cosine theta. And everywhere I see y, I'll substitute r sine theta. So that leaves me with r squared cosine squared theta plus r sine theta minus 3 quantity squared equals 9. Okay. Now I have some simplifying to do here, so I'll go ahead and simplify this out. And I'm going to go ahead and group these two right here. Okay, if I group those guys, then I can go ahead and factor out an r squared, right? And if I factor out that r squared, hopefully you can see that my cosine squared plus sine squared simplify to 1. And I'm left with r squared is equal to 6r sine theta. If I subtract my 6r sine theta to the other side and divide by that r, I'm left with r is equal to 6 sine theta. Now, from a previous lesson, you can hopefully see that this is going to be a classic curve. This is just a circle, right? Likewise, if I look up here, hopefully I realized that this is the equation for a circle, right? With the center would be at 0, 3 with a radius of 3, right? So hopefully I can verify that by understanding what the standard form for my equation in rectangular form is, and use that to verify what I get for my polar form. Okay? So using this exact process, go ahead and see if you can pause and figure this one out, converting this to polar form. And you are going to need, hint, hint, you are going to need your double angle identity for cosine. Okay, double angle identity for cosine for this one. So pause the video, try to figure that out. We are left with a hyperbola here. Hopefully you recognize that right away from the standard form. And when I convert that to polar form, I get r squared is equal to secant 2 theta. Okay, and the graph of that looks something like this. Okay, last example slide here. We're going to write each equation in rectangular form. So doing this, I want to, if I have r equals something, some constant, okay, first thing I should do is try to get that to be r squared. Okay, so I'm going to go ahead and square both sides here, and I get r squared is equal to 9. And I want to get this to r squared because I know that r squared is equal to x squared plus y squared, right? So this is going to be a circle with a center at the origin and a radius of 3, which we can go ahead and graph. If I graph r equals -3, that confirms what I got there. Okay, so this would be our equation in rectangular form. Okay, go ahead and pause the video. If you can do both of these next two, go for it. I'm going to do this last one here, but go ahead and pause and see if you can at least figure out the rectangular form for theta equals pi over 3. Alrighty, hopefully you got y is equal to root 3x, okay? And we just went ahead and took the tangent of both sides, okay? Take the tangent of both sides, and I am left with tangent theta equals root 3. I know that tangent of theta is y over x, okay? So I substitute that in and multiply by x to solve for y. So y is equal to root 3x, okay? And that is just a line with a slope of root 3 that goes through the origin just like this. Okay, for our last one here, I've got r equals 3 cosine theta. Again, I want to get this to have r squared, right? So I'm going to go ahead and square both sides. I get r squared is equal to 3r cosine theta. Now, I know that r cosine theta, right? What is that? That is my x coordinate, right? So I can go ahead and substitute x in for here. And likewise, I have r squared. So again, I'm going to substitute in x squared plus y squared. So that gives me x squared plus y squared equals 3x. Now I'm going to go ahead and subtract 3x to this side. Okay, this should actually be subtraction here. That's a minus sign, not a plus. Okay, so if that's minus 3x, if I complete the square on this, guys, if I complete the square, this is going to be 1/2 squared. That would be 2.25, so I got to add that to the other side as well. So this is going to give me, again, this is not plus, this is minus. Okay, so I got x minus 1.5, quantity squared plus y squared is equal to 2.25. That tells me that I have a circle with a center at 1.50 with a radius of 1.5. And if I graph the polar equation, I can confirm my theory. All right? So that's all for today, guys. That's all I got for you. Good luck with your practice.